course, now we have Mr. Diego's hand, as we usually do. Did anybody solve this yet? What'd you get? You want to put it up there? You already solve it?
I got you in there for the second.
Okay. Yeah. Is this your book?
Yeah.
Okay, don't mind that.
What are you doing?
No problem, man. Like what? Like,
Like your eyes.
first yo, bug out old boy. Old boy.
Not 9. Look, look. What's 9 divided by 3? Right?
Oh, sure.
You want to erase this thing?
No, that's cool. Don't forget, we have a quiz tomorrow.
We just had a quiz.
This,
Whatever we've done this week. Yeah, so this, graphing this thing, and then the thing we're going to do after this. Okay?
We do that, eh, Friday?
Yeah. The only time I don't give a quiz on Friday is if we have a midterm now or something. You know, I don't want to take you with 2 tests. So basically, every Friday, you say, oh, we have a quiz in Keene.
Yeah. Be like second period, first period, like, yeah. Oh man, we got to tackle it. Yeah.
Well, I got to do that today. Today and tonight.
Yo,
I was going to do it last night, but I'm going to have to watch the next one.
Wow, you went?
Well, I didn't go to the game. I went to the bar with a friend of mine.
Hey, Mr. Baker,
World Series now?
They will be, yeah.
they will,
You
yeah.
have
They
to wait
won
to
like
see
4
who they're playing
games.
against. The other 2 teams are still playing, so we don't know.
They
The
won.
the Kansas City Royals and the Toronto Blue Jays.
Yeah, how many games they won? 4? That's a 4 game. That's a game.
I got a what?
You got the first inning, you got the second.
Oh, okay.
But
Good.
I couldn't do it graphically.
That's okay. That's all right. Okay. So to solve, when you solve an inequality, it's the same steps as when you solve an equation with one big difference. What was the difference we learned? When is it different than when you solve an inequality than solve an equation?
May see that again?
Wait, yeah.
What's the big difference when you solve an inequality versus solving an equation? Like, it's the same steps most of the time. Huh?
When are the equals on?
No.
Then I'll.
You said it.
It was graded in less than, or?
Oh. The answers is
No.
not equal to each other.
There's like here we solved this basically the same way as if that was an equal sign, really, right?
Mm-hmm.
The same steps.
So X is equal to
Right. Well, that's true too. But when you're solving inequalities, there's one important difference that you have to do something if something happens.
If you got a negative, you got a sign.
Yeah. If you have what with the negative?
Subtract or whatever.
Not subtract.
Or divide.
Multiply or divide. If you ever multiply or divide by a negative number, you have to flip that symbol. Okay? That's the big difference. Okay? And the other difference is, right, saving, like you said, if this was an equation, we would have got x is equal to 3. And that's just like one number, right? There's only one number that makes that true. It's the 3. If you were to graph it, it would just be one dot, right?
Yeah.
When you solve an inequality, usually you're going to get like a whole slew of answers, Martin. Right? You're going to get like an infinite number of answers, because how many numbers would make this true? What numbers are bigger than 3?
Right.
A lot. An infinite number, right? So that's the other difference, is usually when you solve an equation, you get like one answer. With an inequality, you're going to get a whole range of answers, okay? A whole bunch of them. An infinite number, usually. Good. So then, all right, so she said, okay, the first thing I'm going to do is subtract 11 from both sides, because she's trying to get the x by itself, right?
Mm-hmm.
The opposite of plus 11 is minus 11. And the 11's cancel out, so we have 3x is greater than 20, take away 11 is 9. And then you just divide both sides by 3, and you get x is greater than 3. Since there was no negatives being divided or multiplied, you don't have to flip the symbol here, right? Good, so she plotted the 3 at, she plotted the circle at 3, she left it hollow because it doesn't have the equal sign there, right? And then she said, okay, what numbers are bigger than 3? Well, the numbers to the right, right? Would 3 make this inequality true? If x is 3? Is 3 greater than 3?
No.
So that's why this circle is hollow, because you don't want to count the 3. But as soon as you go past 3, as soon as you go to like 3.1 or 3.007, then it would be true. Because as long as it's a tiny bit more than 3, it would make it true. It just can't be the 3. If it had the equal sign, then we would want to include the 3, you'd fill it in, right? Okay. The second one, Marcus did over here. So we said, all right, let me add 5 to both sides. You get 2x is less than or equal to 26. Divide by 2, you get x is greater than or equal to 13. And I should have made this a little bit, but I'm just going to eyeball it, okay? So 13 would be kind of over here, right? Hollow or filled in?
Close.
Huh?
Close.
Closed, good.
Filled in.
Which way does the arrow go?
The right.
The right?
Left.
To the right.
To the left.
To the
How-
right.
What's that
How
like?
come you flip this one? Marcus, how come you flip this
I'm
one?
sorry.
Oh, you're right.
Was it just a mistake?
Yeah, no mistake.
I thought I was going crazy for a second.
Alright, I don't have to press it.
So, which way does the arrow go?
To the left.
Right, so I put one on top and one on the bottom. So we okay with this?
Yeah.
What if I said, you know what? I want to find out what numbers make this true, and they also make this one true.
Any numbers greater or less than whichever numbers. So that the 3 is greater than, so it would be 4, 5, 6. It's greater than.
So it would be 4, 5, 6 going up to what?
20.
Going up to 13,
Oh, 13.
right? So when I say I want the numbers that are both greater than 3 and less than
13.
or equal to 13, that would be the numbers in between here, right? In between here and here, right? These are the only numbers that would make both of those true, right? It has to be greater than 3 and it has to be less than or equal to 13. So if I was going to draw a graph of this thing, right, it would look like this. See the purple line? That's all the numbers that are greater than 3, but are less than or equal to 13. Does everybody see what I just did? I just said, okay, what numbers satisfy both of these? Well, it can't be over here, because this one, it works for the green one, but it doesn't work for the red one, right? And I can't, like, select the number over here, because it would work with the red one, but not with the green one. So the only ones that work for both of them are the ones in between here. Okay?
Right.
Now, this is what this truth table is. This is called a compound inequality. When you have two inequalities that you join together by an AND statement. So you have one little inequality here, one over here, and they're put together with the AND. And in order for the whole thing to be true, this has to be true and that has to be true. If one of them are false or both of them are false, the whole thing is false then, right? Like I said, right, if I said, oh, guess what, guys?
That's right.
Tonight or tomorrow, I'm going to shave my head and I'm going to wear a dress coming to school tomorrow. So if I come in tomorrow and I have a shaved head, but I'm wearing clothes like this, is that what I said was true?
No.
No. Or if I come in with a dress but with a full head of hair, would that be true?
No.
Right. Because if I say it's got to be this and that, the only way for this to be true is if I come with a shaved head and a dress. Don't hold your breath, by the way. Khalil, come on, sit up. Yasmin. No putting your head down in class. Kevin, come on. Guys. All right, so this is called a compound inequality. The word compound just means like you're adding things together, okay? So you could add actually 3 if you wanted, and everything would have to be true, but we're only going to deal with 2 at a time, okay? Everybody okay with that? This is what's called the truth table for the and statement. If the first thing is true and the second thing is true, the whole thing is true. If the first thing is true, the second one's false, then the whole thing is false. It has to be both of them at the end, right? If the first one's false, the second one's true, it's false. If they're both false, it's false. So the only way with the and for it to be true is if they're both pieces of them are true, okay? You got that?
Yeah.
Another way that I could join these is I could say instead of and, what other words could I use?
Or.
Yeah. So if I said or would say, okay, I want all the numbers that would make the red one true or the green one true, either one. So in this case, all of the numbers on the green would have to be in this thing, and all the numbers in the red would have to be in the thing, right? In fact, it's going to be everything here. If it's or, because they overlap. So to make it something that's true here or true there, it would basically be anything. Okay? What's more interesting is if, I guess, like if I had one where it was like this, and the other one was like that, right? Then it wouldn't be the whole thing. It would like, you'd have to say, okay, well, anything in here would make it true, but anything in here would not make it true. You'll see, we'll do a few more examples, okay? But there's the and the or. So with the or, which one is more easy to be true, the and or the or? Yeah. Which is more easy to be true, I mean? No.
Or.
The or. If I said,
one.
yeah, you only need one of them to be true, right? Watch. So like what I said about, if I said, all right, tomorrow I'm coming in with a shaved head or with a dress on, and I showed up with a shaved head, would that be true?
Yeah.
Yeah.
If I show up with a full head of hair but wearing a dress, would it be true?
Yeah.
If I show up with a bald head and a dress, would it be true?
Yeah.
Yeah. So which one is easier to be true?
Or.
Right. So let me just write with the truth table. Actually, you should write this in those little books, okay? Write the truth table for the and I'm going to do the or now. If they're both, if it's false or false, what's the answer? The whole thing.
False.
So now let me ask my question again. Which one is easier to become true, the and or the or? Yeah, because look, how many ways are there for the or to be true? 3, right? Look. This is true, this is true, this is true. There's 3 different ways for that to be true out of the 4 possibilities. So basically, without even thinking of anything else, you've got like a 3 out of 4 chance for that to be true. What's your chances for this one to be true?
1.
1 out of 4, right? That's a smaller probability, right? So the or is always easier to make come true than the and, right? And it makes sense. It's logic, right? Anybody have any questions about this and or stuff that we just talked about now? I'm going to go into a little bit more depth once I give you the worksheets. But this is almost like not even math. It's almost just like English or logic or something, right? Did you write them truth tables now? You did? Mr. Davis, did you write down these truth tables? For and or? Because I'm not always gonna have them up on the board here, okay?
I'm not feeling it.
I'm quiz tomorrow on this stuff.
It'll be on inequalities and it'll be something on the compound. Yeah, I won't go crazy, but yeah. Can I erase the center stuff here, guys? Yeah. You gotta talk to Mr. Peterman. All right. We don't need to read the top thing. It's just talking about, we're gonna be talking about compound inequalities and the fact that when you solve an inequality, you're usually gonna have an infinite number of answers as opposed to an equation where you usually only have one answer, right? Let's look at exercise 1.
What's the date?
The date? So here we have a compound inequality, right? It's two inequalities joined by an and. So to determine if this whole big compound inequality is true or false, you got to deal with each one individually. Is 7 greater than 3? Okay, so that's true. Is 2 less than 10? So true and true. The whole thing true or false?
True.
True.
Yeah. Right? They're both true, so that's a true.
So we write that true.
Huh?
So we write true.
Yeah, just do what I did. Right? In order to test whether the whole compound inequality is true or false, you have to test each one of the members.
Didn't
Or
you
each one
give
of
us
the
this yesterday?
Huh?
Didn't you give us this yesterday?
No, but we might have done it with,
Cast.
yeah. Okay? All right?
Yeah, I know me. I don't know. I always do this time. Like you think you gave me this one? Nope, this time.
Well, then it should make it easier for you, right?
Yeah. Let's see if I got it.
Okay. So, is 5 less than 10?
Yeah.
That's true.
20 is greater than 11.
11 greater than 20?
Yeah. Oh, no.
So is the whole compound inequality true or false?
True.
False. No. With the and, they both have to be true. As soon as you come across a false with an and, it's false. The whole thing is false, okay? It's got to be everything. All right, so let's look at a couple of ors.
So all we have to do is just write if it's true or false.
But in order to test if the whole thing is true or false, you got to do each one separately, right? Okay? But yeah, just like I'm doing here. Just put a T or an F there. Okay. Is -4 less than 7?
Yeah.
You know what? You don't even have to do this one now. Because as long as one of them is true with the or, you know the whole thing's going to be true, right? But let's do it anyhow. I'm going to write true, but just to prove it to you. Is 8 less than 2?
Nope.
No, so that's false. However, with the or, as long as one of them is true, it's true. At least one of them is true, right? All right, number 4. 3 is greater than 6, or 8
is this
less
and
than
that.
5. So, is 3 greater than 6?
No.
Is 8 less than 5?
No.
So is the whole thing true or false?
False.
Right? That's the only time the or is false, is if they're both false. You got the idea?
Absolutely.
Try exercise 2. Just do what I just did here to determine if the compound inequality is true or false. Okay? And then you can actually do number 3 too, where it just says, it's got 4 of them there, and it says, which of these is false? So they're all true except for one of them.
Yeah, can I use the bathroom?
Apologies.
Probably.
Today's the same Monday.
Oh, justice.
Nigga said this I don't feel good.
I'm gonna do this shit.
3.
So we got a high spot.
You gotta wait for the step.
Yeah, so how you do cartoon?
Oh, they're just talking about, there's two ways to look at this thing. This one here.
That one there.
There's a certain branch of mathematics, actually computer science, that would say, well, wait a minute, if you're saying this or that, if they're both true, that shouldn't be true then. If you're saying it has to be this or that, that should be false. And there is a part of mathematics where they actually say, you know what, that's true. If it's either this or that, if they're both true, that would be considered false. For our purposes, that's not what we're doing. We're considering the or, as long as at least one of them is true, the whole thing is true. Okay?
So we're not to do that.
No. So what, they're talking about, like, if you're talking English instead of math. Kevin, what's up?
Is this one true or false?
True.
True? Because they're equal, right? 'Cause it also says
Yes.
it could be equal.
That's right. You got it. Yeah. Yeah, so for exercise 3, just write anything for B. I don't care. Just say, you don't have to even do B, okay? I'm just interested in that you know how to solve it. Exercise 3, just figure out which one of those is false.
What about two? You're not doing two? Exercise two?
Number 2? No, I said to do that.
Exercise two?
Yeah. Just solve it. Do 2A. You don't have to do B, okay? Just say, determine if that inequality there is true or false. Just like we did here.
Why are you all in my paper?
No, you don't.
This ain't bothering me.
I'm not even bothering
He
you.
was just complaining that he already did this, and now he's looking at your sheet. Yeah. That sounds like Mr. Diego, all right?
I know, right? I could be a triple going. And that first one is wrong.
No, it's not. Leave me alone.
How is 2 greater than 5? Yeah, please tell me that. How is 2 greater than 5?
The
I
last
did
time.
greater than 2.
All right. Here's how I do it.
Yes, it is.
That's
If I
great.
can move again, I'm ready. We did not have problems.
I'll tell you, there's a bunch of different ways.
You really
Remember,
are going to do that?
if, to make those two symbols with your hands, you can only do like this with that. You can't like go like that, sort of, right? So this is your left hand. That's the left hand. Left and left.
Mr. K, come here, please. Is this
Huh?
right?
So what's your answer?
Is this right? True.
Well, that's true, and that's false. But with the or, as long as one of them is true, it's true. So the whole thing is true. So which one of them is the whole thing false? One of those, the whole thing is going to be false. No, because it's an or. As long as one of them is true, the whole thing is true.
Wait.
True or false, right?
So it's
True or false is true. Right? So if it's an or, they both have to be false, or if it's an and, one of them has to be false, or both of them. So just see which one matches that. Yeah, it's a little tricky, but you can do it. Okay, what's up? You don't feel good or something? You know how to do this? Well, it's number 4. Is 7 greater than 3? Okay, so that's good. Is 2 less than 10? Okay. So you have two things that are true. The and, well, look at the thing there, right? True and true, that means the whole thing is true. With the and, if they're both true, the whole thing is true. With the or, you just need at least one of them to line up for the whole thing. So for each one of these, you're going to say, okay, is this part true or false, right? TRF.
Okay, can you answer your question?
Then look at the truth tables. If this is and, they both have to be true. If it's an or, at least one of them has to be true.
You can ask you something.
Yeah.
Right, you have to do the back.
Yeah, well, I was gonna,
Here, Yasmin, you have to do the back.
yeah, I was waiting to see if anybody got the answer for number 3 yet. Who got number 3? Which one of those is false?
4.
Negative 2 is less than or equal to 4. That's true, right? And 5 is greater than 7, right? 5 is not greater than 7. And with the and, they would both have to be true in order to be true. So yes, it's number 4 is the one that's false. Very good. Okay, let's move on. Yep. All right, turn the page over. This truth values thing is just kind of talking about what we already talked about here. Oh, and the other thing is what we said before, right? When we had like x is greater than 3, that's your solution. And how many solutions did we say we'd have that makes that true? Guys.
1.
Huh?
1.
There's only one answer that would make that true?
3. 2.
A lot. Infinite number. Any number that's bigger than 3 would make that true, right? 5 would make it true. 7 would make it true. 11 would make it true. 1,024 would make it true. 6.5 would make it true. 1 million would make it true. 1 million minus 1 would make it true, etc. I can keep going. You want me to keep going?
No.
Okay. So there's a whole bunch of numbers. So instead of saying the solution to this, we say all the numbers that make it true make up the solution set. And the word set just means it's a group of things, okay? So when you talk about what's the solution to this, you always talk about a solution set.
Wait, Keegan, which one are you doing? Number 8?
We're about to do number 4, okay? So if you look in the box above number 4, it says that a value of a variable is in the solution set of an inequality, or an equation for that matter, if it makes it true. And if it doesn't make it true, you say it's not in the solution set. So basically, it's a description of all the numbers. Guys. No, you ain't. Don't even try.
Exercise 4A, right?
Yeah. Don't even try to fool me, man. All right? All right, so look. Exercise 4 says, determine if each of the following values of x is in the solution set to the compound inequalities given below. So it says, is x equal to in the solution set of x is greater than negative 3 and x is less than 5. So we're just going to plug the 2 in for the x and see. Is 2 greater than negative 3?
Yeah.
Huh? Okay, good. So that's true. Is 2 less than 5?
Yep.
Mm-hmm.
So we have an and. True and true. What's the value of the compound inequality? True. And since it's true, you would say, yes, 2 is in the solution set of this compound inequality. Okay? It's one of the answers that make it true. If it ended up being false, you'd say, no, it's not in the solution set. So that's how you're going to do numbers B, C, and D. Just plugging it in and see if it works, okay? Just make sure you remember the difference between the and the or. You got to be careful. Put a little C in it. It's 2 less than 10. So at the end, if they're both true, is the whole thing true or false? So over here, put right true. Okay? That's how you do those. Just test each one individually and then see if it's an and or an or. And go by these truth tables. Are you putting them in?
Yeah.
No. Well, don't put any dirty ones back.
Está bien, pensó.
No, it just says, is x equal 1 part of the solution set? You plug the 1 in. You don't have to solve it. Just plug it in and do the math and see if it's true or false. And it's an and. So you plug the 1 in here. What's 3 times 1? What's 3 plus 8? Is 11 greater than 9? So that would be true. It's an and though, so you have to see if this one's true. If it's true, then the true and true means it is in the solution set. If it's true and false, then you would say, no, it's not, okay? It has to match this, right? So it's only gonna be true if they're both true at the end, okay?
So if we can,
Yeah, but you don't understand what I said?
I got you.
Okay, good.
no, it should actually.
Well, we'll find
I
out.
know what I know.
Yeah. Okay, so now you, for this one, they're saying, is x equal 4, x equal 4 part of the solution set of this thing? So you plug the negative 4 in for the x. Is negative 4 less than or equal to negative 4?
No.
It's equal to it.
Oh, yeah, it's the same.
So it's true. And since this is an or, we don't even care what that is, because the true, as long as you have one true, the whole thing is true. Okay. So you're gonna say, yes, that's in the solution set. Okay? That's it. For each one, you just plug the value of x in, and then you test to see if it's true or false, and then look at your truth tables. Okay? Well, but with an or, as long as one of those true, the whole thing is true. Right? You have to though, because the rules to the and and or are different. Okay? So this is okay, this is good. That one's true. False or false, that's false. Okay. So now here you do another. Yeah, well you have to, because the rules are different, you know? Okay? Yeah. You don't have to solve. I mean, it's okay if you do. The easier thing to do is just say, just plug the 1 in for the x. What's 3 times 1? Would you say that this is what's 3 plus 8? Is 11 bigger than 9? So write true. Then do the same thing. Just plug the 1 in for the x and do the math. And then test. Okay, that's easier. I mean, you can do it that way, but it's more work than you have to do.
What do you think this is? Here's a problem. Probably something 12 divided by 2 is 6.
This last battle, man, when he was on stage with a suit.
For this one?
Yeah.
5 plus 7.
He going hard.
Divided by 2 is 6.
Yeah, that's definitely true. Sure, 6 equals 6.
And T-Rex just had his battle last week. And this one, what's his name? T-Rex.
So,
I think
guys.
it's how hot, I'm not sure.
Plug it in.
I know I did. What's 1 times negative 2?
I don't think this is true. Because look, if you plug 1 in for x, what's negative 2 times 1? And that's negative 2 plus 10. 8 less than 7. Okay, so the whole thing's gonna be 4. But yeah, you just plug the number in and test it, okay? And just remember, you gotta make sure the rules for the and the or are different, right? So that's the main thing, okay? But good, Martin, good job. Oh, I have a quiz to give back to you.
Yeah, you said I did it out of town.
Did I give it back to you already? I saw it.
Yeah.
If I can't find it, I'll at least show you the score.
It's under 55, right?
No, it was above.
Is it passing grade?
For the quiz, yeah.
What? You put in grades already, Keegan?
No, I put in the quiz grades, and I gave you credit for classworks, but I still have some homework to do. All right? And you finished first, I think. Yeah?
Definitely did.
So that's good, man. I was really happy to see that. So some of this stuff is sinking in, Martin. I like that.
Wait, I don't think I have got to take that quiz. I think
You might not have been here.
Yeah.
If you're not here, you don't take the quiz.
I was probably in the hospital.
So you want to take a makeup?
Yeah.
Okay. I'll give you a makeup tomorrow at lunchtime. Okay. But right now, concentrate on this because there'll be a quiz tomorrow on this stuff. Okay.
So,
Let me just jump down. So you know how to do exercise 4? I just want to jump down to the last one. 'Cause it's just something that's just a tiny bit different here. All right, so exercise 5 says, on the number lines below, shade in all values of x that solve the compound inequality. So let's just solve it. So we have x is less than 7, and x is greater than or equal to negative 2. So guys, x is less than 7, right? How do I graph that? Just this part of it. How do I graph it? X is less than 7. Go to 7, put a circle.
And move it to the left.
Okay. Yeah, I was going to go that way, right? Because you'll see in a second. Now let's look at this one. X is greater than or equal to negative 2. So I go to negative 2, right? Put a circle. Fill it in. Good. Because it's got the equal. And which way is it going?
To the right.
To the right. So basically, these two things get joined, right?
Little bit.
Right? This is what the graph of an and compound inequality looks like. The things that make this whole thing true, it has to be true for this one and true for that one. So it's going to be all the numbers between here and here, between negative 2 and positive 7, including negative 2 but not including 7, right? Does that make sense, guys? Somebody say yes or no.
Yeah.
Good. That's always what the graph of an and looks like. It's two dots, two circles with the lines in between, all right? The arrows meet each other in the middle. That's what an and always looks like, okay? Let me just show you what the or looks like. 5b, let me do it on the bottom here. 5b says x is greater than or equal to 5, or x is less than negative 1. Marcus, sit up. Not spit up, sit up. So x is greater than or equal to 5. I go to positive 5. I'm going to do it on the bottom here, okay? Go to positive 5. Do I fill in the circle?
No.
I do. Greater than or equal to 5. What numbers are bigger than 5? To the right, to the left, or to the right?
Right.
Right? So you're going to have an arrow going like this. And x is less than negative 1. So I go to negative 1. I put a zero. I put a circle. Do I fill it in or leave it hollow? Leave it hollow. The numbers that are less than negative 1 goes to the right or the left. Good. So this is what the graph of an or statement always looks like.
Opposite sides.
The or statement is always two arrows going in opposite directions, okay? Look up for a second, guys. Yo, up here. So this is what an or looks like. It's always two arrows going in opposite directions. This is what an and looks like. It's two circles with the arrows going together, meeting in the middle, okay? So if I just showed you a graph and it looked like this, you'd say, well, I know that's an and statement, okay? If it looked like that, you'd say, well, I know it's an or. You should be able to recognize those, okay? Now, what we said before about which one is easier to make true, the and or the or? Good. And doesn't that look like that's the case? Like, which one looks like there's more answers, the blue or the green? The green? Oh, the blue, good. Because look, it keeps going forever this way and going forever that way. The only ones that don't make the blue one true are the numbers between here and here, which is only like, a few numbers, right? Meanwhile, everything else on that number line is a solution for it. Whereas the and, everything to the left of here is not part of the solution. Everything to the right is not part of the solution set. So the only things that make this one true are just those numbers there. Got the idea?
Yeah, well, wait. But can't they, aren't the lines supposed to keep going?
This one? No. Because this one with the and, in order for it to be true, it has to be less than 7 and it has to be greater than or equal to 2. So it's only the numbers in between there.
I get it.
That's what the and always looks like, okay?
Get it.
Let me just make copies of the homework here.
That's Keyshawn and DNA, bro. Keyshawn body on that, bro. Body, Keyshawn killed him. They made two of them. They made two. They had a rematch since two. Yeah, they definitely.
Miss guy,
Keyshawn killed him.
Miss Nigel,
Keyshawn really killed that nigga, bro.
teaching
They had a round two after that, no?
You see, they were in the ring, it was a boxing ring. For that tag team shit, he's
DNA going in right now. DNA has never got beat yet. DNA listed just them two. DNA Keyshawn fight, but he's still not yet, bro. Like they only getting right now.
One team that probably beat them if they come together, that's Team Rock and Shoe Serve.
No, not even.
Nah.
Sue Surf is good, but he's not all that, bro. He lost. He
They
lost to this.
about to do a rematch. Keyshawn and Shoe Serve. We're gonna kill them again, bro. Shoe Serve gonna kill them. Keyshawn lost the first time.
Guys, make sure you do this because there'll be stuff on the quiz for this one, all right? Go.
Oh, that is wow. He's body.
Put one on your desk. You're right.
Tell you, bro, that's what I got on my phone when I'm on the train, bro. That's what I listen to, bro. I have a train with a snake, bro.
Nah, I'm not saying he's not trash. He got bars. When he in New York, he just.
What's his man's name, bro, from Portland?